I'm making a separate video for this because these kinds of problems, solving a differential equation, we're going to use pretty much the entire rest of the year. So if you forget the process, you could just come back and watch this one video. Although this is with some basic integrals, we're going to do the same thing in the future, just the integrals themselves will get more involved, and sometimes we'll have variable issues that we need to talk about. But essentially, when I tell you to solve a differential equation, or if I say find a general solution to a differential equation or a particular solution to the differential equation, it all means pretty much the same stuff. We're going to solve a differential equation, which essentially means I'm giving you a derivative. Have you come up with the original function? Or I might be giving you the second derivative. Have you integrate once to get the first derivative, then integrate a second time to get that original function? But we're just going to integrate both sides. Remember the plus c. And if they don't give us any points, that's going to be called a general solution. We'll pretty much be done. And that represents a whole family of curves. I'll show you that in a second. But if they give us a point, then we're going to use that point to plug it in for the x and y to figure out what that c value is. So we're just going to practice our integral techniques there. So these are the two examples we're using. Those are the steps if you just need to watch that for the refresher. And then we're just going to fly through these two examples, all right? So first one, I give the derivative. I want to find the general solution to the differential equation. Now, our book is going to say solve a differential equation, but the language on the AP test is finding a general solution to the differential equation. So essentially, this is what you're doing. You're going to multiply both sides by the dx. And notice that you have x's with the dx. In the future, we might have a combination of y's with that dx, and we'll need to move that over. We'll get that with the dy, but we'll learn those things in the future when we get more involved there. So essentially, all we're going to do, this is your derivative. You're going to integrate both sides. Now, we integrate one with respect to y, you just give y equals, all right? And that's what we're doing. We're coming up with the original function. And then you're going to integrate this. This is our easy power rule. So we're going to carry the 2 down. We're going to add 1 to the x point. We're going to divide it by that same number. Technically, I integrated both sides, so I got my plus c involved. And then those will cancel out. So this is just going to be -1 over x squared plus c. So all you're doing is you're integrating both sides, but since it's a differential equation, we really need to have y equals and on just these kinds of problems right there. So if you're solving a differential equation, make sure we got y equals there and you're coming up with that original function. All right, so there you go. And that represents a whole family of curves depending on what that c value is. And again, on the AP test, the language will stress find the general solution to that differential equation. Notice we don't have any points to plug in for the x and y, so we can't obtain that c value. We don't know what that is, and so you're just done right there. So just integrate it, remember the plus c. And then here's another example. So I'm going to give you the derivative, and this time I'm going to give you a point, and we'll say solve the differential equation. Either you'll see that, or you'll see find the particular solution to the differential equation, and they'll call this like the initial condition where we're going to use that point. So we'll use that point at the very end. And so I'm just going to go straight to the integrating right here. So anytime I got to solve a differential equation, I'm going to integrate both sides, remember the plus c, and then use a given point to plug it in to figure out what that c value is. It's a very simple process. All right, so what I'm going to do is just integrate both sides here. And so when I integrate the g prime, you know that's going to give us the original function. That's going to give us g of x, and then just integrate that. This is our easy power rule. So that's going to be 6x cubed over 3, which is going to represent 2x cubed. But you have an indefinite integral there, so you got to put in that plus c. So this is the general solution to the differential equation, but we're not done there because they give us a point. Anytime they give you a point or an initial condition, what you're going to do, that's your x value, that's your y value. You're going to take those points, you're going to take those numbers and plug those in place for the x and y. So I'll take the -1, plug it in for the y. I'll take the 0, plug it in for the x. And then you use that to figure out what your c value is. And then once you obtain that c value, you could plug that back into that general solution. And here is our final answer. We're going to get g of x equals 2x cubed minus 1. So this is called the general solution with that plus c in it. But when they give you a point and you plug in that point to figure out what that specific c value is, that's called the constant of integration. Boom, right here, this final answer, this is your particular solution to that differential equation. Just a couple little things there. This c value will not always be the same as that original y value right there. It could be, it might seem like it just because right now we're doing some very, very basic integrals. In the future, the integrals themselves will get more involved, and that c value will often be different than that right there. So don't assume that, but what will always work for you is simply take the point, plug it in to figure out what the c value is. That will always work for us, okay? And that's going to be the same exact thing that we're going to do a lot of on the AP test right today. Love differential equation problems. And there's a whole entire class in college called differential equations, where the things just get more involved, the variables get a little bit more challenging, and you got to separate things. And we'll learn a bunch with that this year, and then there's a separate college class where it gets more advanced. But what a general solution is, like if you graph y equals 2x cubed, you know that's your x cubed graph, which looks like this. And depending on, like, if it's 2x cubed plus 0, or 2x cubed plus 1, 2x cubed plus 3, 2x cubed minus 1, 2x cubed minus 4, that's what they mean by the general solution with that plus. See, it's a whole family of curves. And when you're finding the particular one, when you found this equation, you found the precise one that goes through that point, 0, -1. You found this equation right there. So just make sure you just get that process down. And then when we see those in future sections, you shouldn't be asking me, oh, how am I supposed to do this? You could just rewatch this video, but that's what you got to do. Integrate both sides. Remember the plus c, use the point to plug it in to figure out what that c value is. And then, like I said, we'll just give you more involved integrals in the future, but the process is going to be the same. Just like when we had derivatives, we had each section had to write the equation on the tangent line, but when you just did different methods in order to find that derivative here. So we'll just do different methods to integrate it, but that process is going to be the same about how to solve a differential equation. Thank you.